Hello everyone, I will start a series of lectures. We will follow all of statistics by Larry Besserman. We will start this lecture by giving you simple definitions, sample space and events. What's a sample space? The sample space is a set of possible outcomes of an experiment, and any point in a sample space we call that sample outcome or realization or any element. And subsets of the sample space we call that events. To give an example, we take a coin, an unbiased coin. So when we toss a coin twice, our sample space is going to be head, tail, head, and tail. So let's say we want to see what the first toss is heads. In this case, it's going to be HH and HT, and we define that as A, event A. So sample space does not have to be always discrete case. If you look at this 1.2, we will see that our sample space is now infinite. In other words, whole real line. So we can take event A that's interval including 10, but goes until 23, and excluding 10, but starting from 10, excluding 10, and goes until 23, including 23. So that tells me my temperature, in this case omega, an element or realization of sample space is at the measurement of the temperature. So in this case, we say that temperature is between 10 and 23. So we just see that our sample event is finite in both cases, but we can toss a coin forever. In this case, my omega is going to be infinite sequence, that omega 1, omega 2, omega 3, but omega I may take H and T. So we will have infinite long sequence. So if you want to define event in this case, let's say let E be the event that the first head appears in the third toss, then we say V1 is tail, V2 is tail, and V3 is H, and the rest is going to be, it can be H and T. So that's going to be the event A, that the first head appears on the third toss. So what is A complement? A complement if you wanna show where the set, so this is my A, this is my whole space omega, then A complement is going to be this part. Okay. Now what's A union B? So, and now assume you have another set B. So A union B is going to be, now let's get different color, that's going to be A union B is this part, which is, so A union B is in this part, and let's throw this then, this is A complement part. Now we can also show what's A intersection B. In this case, this is going to be this part. A intersection B as the blue shaded area. Now for the terminology, you can take a look here. Omega is a sample space, small omega is outcome or point in that sample space. A is event, A complement is everything besides A, and A, we showed A union B, A intersection B. We also sometimes use this notation. And A minus B, or set difference, and A subset of B, this is a null event, empty, and this is whole space, the true event, always true. A disjoint B, in this case, to show that A1, let's say, and A2, we call that they're disjoint because intersection is empty. we will stop here because we finished section 1.11.2. In the next lecture, we will start explaining some axioms in probability distribution.